Alright, in this video we will look at this question that was sent to me by a student who was just sure that this is the right answer, but it actually is incorrect. So what we're seeing here is that we were asked to graph this inequality, and this is the answer the student came up with. And it's incorrect, and I'm going to show you why it is incorrect. First of all, the line is actually correct, and it's dashed, which is correct because we have a strict inequality symbol, meaning there's no equality involved. So we would not want a solid line, we want a dashed line. We also can see that the line should go through the intercepts that are shown on the graph, because if you were to plug in a 0 for x, you would have a 0 for the x value, which would mean it's going to be on the y-axis, and this whole piece would zero out. And so then you would just have this term left, which you can solve for y by dividing by 3 on both sides. This will become a 1, and then you'll have y equals -4. So the y-intercept is at -4. Okay? We can also see that the x-intercept should be -3, basically for the same reason, because when we plug in a 0 for y, we're going to have a point with 0 in the y position, which means it's going to be on the x-axis. This completely will zero out, this entire term, and then we'll just divide by 4 on both sides to get x equals -3 as the point for my x-intercept. Okay, so far that's good, and then we have the dashed line since this is a strict inequality symbol, and now we just have to decide which side to shade it on. Well, there's a couple ways you can go about it. You can pick a point. Let's just pick a test point. Let's pick this point down here that's in the yellow shaded region. That's the point 1, comma, -6. And I'm going to take my inequality and I'm going to replace the x and the y with the coordinates from this point and see if it makes this true. Okay, so what we are looking for is to see if, that looks almost like the number 7, it's supposed to be a greater than symbol. But we want to know if this is true. If the left side of the equation is indeed greater than the right side when we plug in the coordinates 1 for x and -6 for y. All right, so let's simplify this. We get 4 here, -18 here, which simplifies to -14. Bringing down the inequality symbol and the -12, we see that this is a false statement. -14 is actually less than -12. And you can see this on a number line, right? If you just make yourself a number line and you had -12 down here, you would have to keep going down towards the left, -13, then -14. And so -14 is actually not greater than -12. So this is a false statement when you plug in the blue point coordinates. So that means instead of shading toward that point, you would actually want to be shading away from that point. So the correct answer, the only difference between the answer the student gave originally and the correct answer is just the direction that they shaded. Okay, another way you can tell which way to shade, sometimes if you prefer, you can solve for y. So just take your original equality and get y by itself. So we're going to do inverse operations. We'll start by subtracting 4x from both sides. That'll zero this out. Then we'll have 3y is greater than -4x minus 12. Then to get y alone still, we'll undo this multiplication here by dividing. Make sure all of the terms are divided. And then we have an equivalent inequality statement that y is greater than -4/3 x minus 4. So notice that using the y equals mx plus b form, we see a y-intercept here at -4. And then using the slope, we can go down 1, 2, 3, 4, and to the right 1, 2, 3 to land on another point. Or we could have gone up 1, 2, 3, 4, and backwards 1, 2, 3 to get another point that is on that line. Okay, so that confirms the line is correct. But what about the shading? Well, whenever y is by itself, it says y is greater, which means that you shade above the line. So this would be above the line. Okay, so that should be the right answer and not the shading below.